In this second part, we are going to be looking specifically now at functions. So, join me, algebraites, as we learn about functions. A function is a special type of relation that has each input assigned to exactly one output. Graphically, this means that it passes the vertical line test. Let me explain that, and then down below we'll see it. Is that any vertical line will intersect the graph no more than once. So it can intersect no times, or it can intersect one time, but not twice or three times, etc. If no element in the domain mapped to the same element in the range, then the function has a special name. It's called one-to-one. And actually, just as a side note, you could do the horizontal line test to test for one-to-oneness. So let's unpack a little bit what I mean by things here. So in the world of relations, kind of like a Venn diagram here, we've got a whole bunch of things. Any set of points, 1 to 2, 2 to 6, 3 to 5, whatever. Okay, so these are relations. But within relations are functions. And functions are special because they have unique characteristic where each element in the domain maps to exactly one element in the range. And deeper within functions, we could have one-to-one function. One-to-one. Okay, so just to summarize here, all functions are relations, but only some relations are functions. Okay, so let's take a gander here. Determine if each relation is a function. If so, is it one-to-one? So let's see here. The negative 3 maps to a negative 5. The 6 maps to a 7. But the negative 3 here maps to a different number. A different number. So it's an inconsistent situation. So here it is not a function. And why is that the case? In a mapping diagram, we can see that the negative 3 maps to a negative 5, but also maps to a 4. So it's the split here that causes it to be inconsistent. Now let's look at the next one here. The negative 30 maps here, the 20 maps to 20, negative 10 maps to 10, and 0 maps to 0. So because it's consistent, every single time I see a negative 30, it maps to this specific number there. So this one is a function. Now, more specifically, is it a one-to-one function? Well, so with functions, we're looking for repeats here. Repeats. When we have a repeat, there's a good chance that it will be a not function. Then over here, for one-to-one, we're looking for repeats over here for one-to-one. Since there is no repeat in the domain, range, then it is a one-to-one function. In other words, not more than 1 over here maps to the 20. And over here, let's take a gander. Notice we can quickly see that the 2 splits off into 2 separate outputs right here. So this one is not a function. We already know it's not a function, but see this 1 right here, how I map from the 3 to the negative 2? It's also not going to be a one-to-one function because of that right there, if this weren't true here. All right, the next thing we want to do is practice the vertical line test. So we're going to find the domain and range of each relation. We're going to use the vertical line test to determine whether each relation is a function. So first, we're going to graph the ordered pairs, but also write the domain and range. Once we graph each of these points, graph this relation, we can quickly see what the domain is, because the domain is just the x value of each of these points, kind of like you're projecting your a shadow onto the line, onto the axis to see what you get there. So in terms of domain, we can just make a quick list starting over here at negative 3, then a negative 2, then a negative 1, then we get a 0, 1, 2, and 3. Now for the range, we're just going to project this way. So there's a 2 right there. We're going to project here to be a negative 3. So the range, the smallest it gets is negative 3. Then we have a negative 2. Then we have a negative 1. We have a 0. We have a 2 and a 3. Now, is this a function? Well, vertical line test says this. There's a vertical line right here. Let me just draw one real quick. Here's a vertical line right there. So I just want to test this to see if it does indeed pass. So here it only crosses once. Here it crosses once, 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 and once. So I took it all the way across. So because of that, since no vertical line intersects the graph at more than one point, the relation is a function. But let's test down here. Notice all I have to do is take this line here and test it across there. Notice it intersects exactly once here, but here it intersects twice. It intersects there and there. So I can instantly say that this one is not a function. Why? Because it fails the vertical line test. All right, it is your responsibility to work through these guys down here, and you can be using your vertical line test to check those. On the last page, we're going to look at real-life sort of things, and that is we're going to have constraints on domain and range. So let's see, for example, here. A hose is filling a 10,000-gallon swimming pool at a rate of 10 gallons per minute. Well, let's consider what our units are, okay? Right here, I'm weighting, so x is sort of the number of minutes that I am filling up this pool. And my y value is going to be the gallons. My y is going to be the gallons, the number of gallons. Now, practically speaking, let's see what we can get. Can I wait 0 minutes? Well, if I am waiting 0 minutes, then officially I haven't actually started filling it, right? So my domain, and I'm just going to use the D here for domain, my lower limit is 0, okay? But it doesn't actually include 0 because at 0 I'm not filling the tank. So here's my x, the number of minutes that I'm waiting, greater than or less than or equal to. And notice this, it does have a max though. Once I fill up 10 gallons in 1 minute, I could fill this whole thing up in 1,000 minutes. So here's my domain. My domain is greater than 0, but it's got to be less than or equal to 1,000 minutes. So that's my restrictions. What about my range? Well, practically speaking, my range is going to also not include 0 because then I haven't filled it or started filling it, all the way up to 10,000 gallons. Now notice that I can have in between. I can have decimals. I can wait 2.6 minutes. I can fill something up 1,242.7 gallons and anything in between there. This one here, though, has a little bit more restrictions, and let's see this one. A restaurant needs to order chairs for the table. One table can accommodate 4 chairs. So we do know that in order to keep consistent here, for every one table, we're going to go with 4 chairs. Well, what are some restrictions here? If we talk about the number of chairs, so x being the number of chairs, we have some restrictions on that. What are they? Well, can my domain include 0? Well, not really. Sorry, not number of chairs, but number of tables. Can I have 0 tables? Yes, but then I'm not actually doing anything. So I can have 1 table, but I can't have half a table. I can have 2, I can have 3, etc. And the question is, what's the max? And that's going to be dependent on the venue, but there is a max. So I'm just going to write down max just because we know that there will be one, maybe 100 tables, maybe, but clearly not 1,000 tables, right? Okay, now what about my range? Well, my range is whatever my domain is times 4. Whatever my range is times 4. So 4, 8 chairs, 12 chairs, ... 4 times whatever my max is. Again, that's going to be dependent on the situation. You're going to check these out, and you can pause and then check your answer here. For this one here, I decided to consider, well, gallons of gas is going to be X, that's the input. And for a car, and we are making that assumption she buys different amounts of gas at 225, let's just go with that. For a car, maybe 20 gallons is the max of her car. Now, it could be that she has a very small car, so that number might change. She could have a very large truck where that's going to be larger. But this is at least reasonable where we're considering it out. Whatever the answer is over here, we're just going to multiply that by $2.25 there. However, the bowler, he's got different restraints. X is going to be the number of games. Okay, so with that in mind, he's not going to play 0 games because then he's not playing. So the domain is going to be 1 or 2, etc. And there's a maximum amount. What's reasonable? I don't know, maybe 10, 12. But really, you're not going to go much more than that because do harm to yourself. Now, the range, of course, is going to be whatever this is times $2.75, and we'll stop it there. The last thing you're going to see on occasion is this idea of continuous or discrete functions. A function that is continuous has a domain of all real numbers. All real numbers. Another way to simply consider it, although that's not a perfect situation, is that you just don't need to lift your pencil when you're drawing it. Lift your pencil while drawing it. So take, for example, here. This is a continuous function. La, 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 la. And then arrow there and arrow there. This is a continuous function. La, 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 arrow there, arrow there. And the same thing here, a parabola of some kind, arrows on the end. I don't lift my pencil except to do the arrows. Now, a non-example, what if I had this discrete function right here where I was doing this, la, 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 something happened, and now I'm up here. Do, 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 and I'm continuing that going. Well, because of the gap right here, it's discrete. It has a break in it, okay? If I were to take this function right here, la, 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 there's a hole for some reason, la, 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 like that. This is a discrete function. And the same thing holds true. So there can be a gap, or I could be talking about dashed or something like that, or a step function that looks like this. These are discrete because I'm lifting my pencil as I am drawing it. All right, that concludes functions and relations. Enjoy your algebraic day.